My name is Dr. Esther Trufan, and in this video, we're going to explore solubility. The definition of solubility is that we're able to dissolve 1 gram of that compound in 100 grams of a solvent. If that solvent is water, we're making an aqueous solution. If it is not, then we're going to make a solution using a different solvent. However, most rules explored in the context of this video will relate to solubility in water. If we're trying to dissolve a molecular compound in water, it is important for that molecular compound to be very polar and ideally contain some opportunities for hydrogen bonding. Here is the example of sucrose, which is regular sugar, and we see a substantial number of OH groups. All of these are opportunities for hydrogen bonding between sugar and water. So this explains that we can dissolve a very large amount of sugar in water, especially if we warm it up a little bit. When it comes to ionic compounds, their solubility depends on this balance between their hydration energy and their lattice energy. Lattice energy is the energy that holds the ions together in a crystal. And so we need to extract each ion from its crystal lattice so that it can be surrounded by water. Now, every time an ion is surrounded by water, that produces some amount of energy that we call the hydration energy. If the hydration energy is higher than the lattice energy, then it is possible for the ionic compound to dissolve. Sometimes a little, sometimes a lot. The solubility of ionic compounds has been studied for a very long time, and these days it is very common to find that information tabulated in various forms of the solubility table. And here are some examples of the solubility table. It could be just a list that follows the same pattern that says these compounds are soluble, and when something isn't, then that goes in the exceptions category. The most common, though, is where we have this two-sided table, one for the soluble compounds with exceptions, and one for the instances where the compounds containing these ions are going to be insoluble with some exceptions, and these exceptions then go back to some of the things on our soluble list. There are a couple examples that we already know from our laboratory experience that are ionic compounds that are soluble in water. One example is sodium chloride. Sodium chloride, or table salt, contains sodium, which is in group 1. And we know from the soluble part of the table that group 1 metal cations are always going to be soluble with no exceptions. So any compound that contains sodium, this could be sodium chloride, sodium bicarbonate or baking soda, sodium carbonate or washing soda, these will all dissolve in water because they contain sodium. Now, another compound that will show up frequently in your laboratory is calcium chloride. Calcium is not in the group 1 category, but it's in group 2. So that doesn't fit any of our soluble categories. We can look at the chloride because calcium chloride contains chloride. So chlorides are mostly soluble with the exception of silver 1, mercury 1, and lead 2. Calcium not being an exception makes calcium chloride soluble. Another one that may show up is calcium carbonate, and we find the carbonate in the insoluble group. So it is mostly insoluble with the exception of group 1 metals and ammonium ion. Calcium is in group 2, so calcium carbonate is not going to be soluble, but rather it will precipitate out from an aqueous solution. Another compound that you may come across several times is acetate. Sodium acetate, calcium acetate, and the like. And we find that all the compounds that contain acetate are going to be soluble with no exceptions. Identifying a variety of compounds and determining using these tables whether they are soluble or not will be helpful when starting your experiment or when deriving your conclusions based on the experiment that was just conducted.